Okay, actually, the preceding video, I called that 1.3. I used the quadratic formula to solve some equations, and actually, that's not even part of the first block of assignments, but that's something that you pretty much know how to do, so I'm going to leave the video in there. And I'll also repeat it when we get the second set. Okay, so what we're told here now is that the vertex of a quadratic function, we're trying to find, we're looking at the vertex of a quadratic function, and we're looking at that both in problem 3 and problem 4. Now there's an error in problem 3, and the error is simply that the x-coordinate that's supposed to be for the vertex of that function isn't the x-coordinate for the vertex. Now that's going to be corrected in the next batch, so after this week that'll be corrected. Doesn't matter too much. You're going to be able to substitute the number that's given into the function, and that's all that we're really interested in doing. So, and I think we specify the function, we call it f of x instead of y. And we could say y equals f of x equals and so forth, as we usually do. So the vertex of this function, if I did this correctly, is at x equals 3/4. So the question is, not how I found that 3/4, that's the next problem, but the question is, how do we find the y-coordinate once we found the x-coordinate? Now the x-coordinate's easy to find, but people miss the step of finding the y-coordinate, which is why I do that first. I give you the x-coordinate, ask you for the y-coordinate. So what's the answer going to be? Well, if the x-coordinate is this, the y-coordinate means, the vertex is on the graph, okay? It's on the graph at the point where x equals 3/4, so the y-coordinate had better be what you get when you plug in 3/4 into this function. So, y equals f of 3/4 equals 2 times the square of 3/4 minus 3 times 3/4 plus 7. And that's 2 times 9/16 minus 9/4 plus 7, which is 9/8 minus 9/4 plus 7, and I'm not going to go through the details of the fractions, but we have to have a common denominator, and it's going to be 8. So we have 9/8, and then we multiply both the 9 and the 4 by 2, we get an equivalent fraction, 18 over 4. And 7 is 28/4. It's 56/8, and this is not 8/4, this is 18/4, this is 18/8. Sorry. Okay, so multiplying numerator and denominator here, multiplying the numerator by 2, we get 18. Why did we multiply by 2? Because we've got to multiply the denominator by 2 in order to make it match this one. So, multiplying denominator by 2 gives us 8. Numerator had to be multiplied by 2, we get the 18. And 7 is 56/8, and you should certainly know why that is. So this is 9 minus 18, which is -9, plus 56, which is 45/8. If you want to know where that is in the number line, it's 5 5/8. Now, anytime you've found the x-coordinate of the vertex, you plug it in to get the y-coordinate. The vertex is, or should be, three-fourths. And I'll write it in mixed number form so you can think about where that is on a graph. X would be 3/4, y would be 5 5/8, so the vertex would be like right here. And the parabola would either be above, the vertex is the low point. It might be where the vertex is a low point. It might be where the vertex is the high point. And the graph might be fatter or thinner, depending on what vertical shifts and what your coefficients are and so forth. Okay, So we're not going to worry about that part though. All we're worried about here is if you know the x-coordinate of the vertex, you plug it in, you get the y-coordinate, and that allows you to plot the vertex of your parabola. Okay, well, this would be 1.4 here. So we're going to go on to this. We're going to find the vertex of this function, and that's going to take just a little bit of explanation.